help with number 1 on the study guide. Here it is. The list below shows the height in inches of each girl on this high school softball team. It gives you the raw data here. And then it says which histogram represents this data set. So, few things you need to remember about histograms are what? What's special about histograms? Yeah, intervals. Okay, the y-axis, not the y-axis, the x-axis has intervals, and the intervals must be even. Meaning, like, you can't have one bar that represents 10 numbers and the other bar represents 5 numbers. Like, you can't do that. So like 60 to 61 and a half, and then it goes to like 62. Well, what if I had 61.9, right? Like that doesn't make sense, we're missing numbers. So automatically that first one doesn't make sense at all because it's missing numbers. This next one, same thing. Are they all about? Okay. So I take issue with some of this. Let's see, but on your test, the one that you're taking Tuesday, that could be something that helps eliminate answers is looking at the intervals. So just remember that for next week. Let's just see then. Let's see how these are different. It looks like they are all different. On the 66 to 67.5, you see that? How each one has a different level. So I'm gonna use that to help me find my answer. So anything that goes from 66 to 67.5, I'm going to look at right now. That one. That one, not 64. Okay. Let me double check. So I have that occurred twice. In this data, numbers from 66 to 67.5, therefore, I think the answer should be A. So let me see. That one says the wrong frequency. That one says 2, so it's between either A or C. We've eliminated B and D, so let me write that off to the side. So B and D are definitely not it. So now compare A and C, see what's different between those. So let's look at numbers that fall between that interval. And we have 62 counts for this one. Because it does, even if it was right in the middle, it would count for this bar. Let's see. 62. It would not, it would count for this one because it like has a gap in the intervals, so we would include that one. So I counted just 3, which means that my answer is definitely A then, because the other one had only 2. But let me double check the key. Or the other one had it at 4. So I counted 3. So I would go with A, and according to the key, that is right. I don't know if we did in your class, but we could look at it now. Did you have a question on it still? Oh, yeah. All right, other questions at all from any study guide, the paper one, like especially if you didn't understand something, or this one? Yes. The egg one. So keep in mind, not everyone has the same algebra class, so I think only one of my classes asked about this, so if you already know, just hang tight, maybe don't say the answers if you reviewed it already. So a grocer thought she needed safer packaging. She counted the number of intact eggs in 24 cartons from the cooler. The dot plot shows her data. And we have to answer all these questions about it. So first, the distribution, meaning like the shape of the intact eggs is skewed left, skewed right, roughly symmetric, or used. Think about it while I answer this. Yeah. Miss Medina. Yes. If you could not. But how would you describe the shape of this distribution? To the left is correct. So where do I tell you to look so that you get the name right? Look for the void. Don't look at where all the data is clustered, because then that's confusing. It's skewed left. Because that's where the void is, for one, that I think helps. And also because that means that there's probably an outlier. That's the reason it's skewed left. It's pulling the mean to the left, like making the mean smaller. So that's why we call it skewed left. Otherwise, just look for the void. The median, so my middle number, I know you can't cross out on your computer screen, but you might be able to count like where your middle would be. What's half of 24? 12. So it told you there was 24 data points. Since this is an even number of data points, I would expect two numbers to be in the middle. So you could go like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Here's my middle. It's between this 11 and this 12. Like if I wrote them all out in a list, and those are my two in the middle that I'd have to average. So what's the average of 11 and 12? 11.5. Okay. So 11 plus 12 is 23. Divided by 2 is 11.5. So there's that. You could also type it all up in Desmos and find the median that way too. Then we have the mode of the intact eggs is, I don't know if you have a mode button in Desmos, let's see. But what does it mean when it says what's the mode? What does the word mode sound like? Sorry. Okay, it doesn't find the mode for you. So, sorry. But what does mode mean? Yes? So it has to do with something that frequently shows up in the data set. It's like your most, actually. So, you can't even type it in either. It just doesn't work, sorry. But you have to remember, mode is most, the most common occurring data point. What is the mode of this dot plot? 12, it has the highest frequency. So the mode of the intact eggs is 12. And there are no potential outliers or some potential outliers. Some. Anytime it's skewed, usually there is a potential for outliers. Reason we say potential is because you actually would need a formula to prove it's an outlier. I don't think you need the formula for the test. I taught it to you, but you can kind of eyeball it most of the time and assume it's an outlier. So this is a potential outlier. So there are some potential outliers. Now, does removing the data point 6 change the IQR? How do you find IQR? So your IQR should never be negative. It has to always be your bigger quartile minus your lower one. Okay, so Q3 minus Q1. Now I've taught you how to find both of those by hand, but it is a little tedious, I'm not gonna lie. What I would think is probably easier, especially since we're now having to find two IQRs basically, is I think using Desmos for IQR would be easier than doing it by hand. That's what I'm gonna do. I'm gonna type in my data over here. Remember, I can't help you with the calculator on the test, so make sure you know how to make your calculator think, and that's by typing this in. And then I'm gonna type in the data. I had 10 11s. And then 12 12s. And it said 24 element list. I had 24 data points, so that's a good sign. That means I probably typed it in all right. And if I'm trying to find IQR, what did I tell you finds it or helps you find it a bit easier? Typing in stats. Where? Oh, it is right here. I never saw it there. I've been telling everyone they just need to memorize it. But it is right there if you ever want to take a look. This one, stats, and then parentheses, whatever you called your data. Here's your 5-number summary. That's what you need for a box plot, by the way. But we just care about IQR right now. So Q3 minus Q1, what is 12 minus 11? 4. Okay, so my IQR before removing the 6 is 1. The question is, does it change if we remove the 6? So let's see. I'm just gonna delete the 6. Did my IQR change? Because it's still 12 minus 11, which is still 1. So, no, it doesn't change in this situation. I would recommend doing that to know for sure, because sometimes it changes, sometimes it does. Questions on that? Okay, questions on any others? Might have time for one more. Massimo?
Question 2.
On the first study guide, like the purple one?
Yeah.
So a sample of 10 boxes of raisins has these weights, and we are making a box plot. So what I would recommend, I showed you how to make a box plot by hand, but I would recommend for this one, use Desmos, use the stats button, because then it'll give you the 5 numbers you need to make a box plot. You could also make a box plot in Desmos with the box plot button, but let's just, I think this would be easier, so hang on. All right, always make sure you typed in all your data points. So it says 10 element list. We're talking about 10 boxes of raisins, so that's a good sign. And your 5-number summary. These 5 numbers that you get from pressing the stats button is also what you need to make a box plot. So that should hopefully help us find the right answer. And you hopefully can read a box plot, right? Like what line is for the median? This middle of your box. So see what answers you can exclude. Like I would start with median, I think that's easiest. I can't exclude A yet. I can't exclude B because the middle line of the box is not on 32, right? It's on 35 or something. Is this on 32? So you can eliminate C. B is on 32, but now I have a 50-50 chance. So see what's different between this one and A. So definitely like the quartiles are different, the edges of the box. Does this data best match A? So A is the answer. It has a minimum at 25, Q1 at 29, Q3 at 35, a maximum at 38. A, and then there was other parts of it. What percent of boxes have a weight above 29 grams? So I'm gonna look at A because that's the correct box plot. 29 is here. What percent is more than 29? 75%, because remember your quartiles divide your data into quarters. So here's my first 25%. Here's my second up into the median. Here's my third, and then from here to here is my fourth quarter of my data. So more than 29% would be here, so 75%. And I kind of skipped one. About half of the boxes sampled have weights above what? So what's my halfway mark of my box plot? 32. So you would say above 32. This one, I think is number 2. So A, 32, 75. Good. So keep studying. Some of you, I think, like something that you well.
My song,